As you can see on this board is created by students, and the name of this team is called Unix. Around 5 to 8 students were involved in creation of this. As you can see, the first stage of our program is identifying a problem statement by communicating with the local community to find a problem. Now, in this case, students have come up with a problem which says that they are committed to solve for societies who use polluted water, which helps them to understand the importance of clean water and gives them benefit of living a healthier life. Now, the framework which you can see the answers written is given by Erehwon team, and they have just followed the framework to create a narrative of problem statement. Once this problem statement is captured, we can see it in real time and give the feedback to the students that whether there's a correction to be made in this problem statement or you can go ahead. Right now, this looks like a good problem statement to me. So I will say go ahead. Now, the next step of this process is writing proper questions and asking them to the community members. In this case, you could see that there are a lot of questions that the students have written down and gotten answers back for them, which help this process helps them to understand the problem in much deeper way and generate insights for the same. Now let's look at how these students have implemented the ideation process. In the middle, as you can see, they have written the problem statement, cleaning the polluted water. The next stage is writing down whatever random ideas that come to their mind to solve this problem. In this case, putting logs and extracting all the wastes, water pumping, earthen pots which clean water, alum, iodine addition, plunging, aeration increases dissolved oxygen in water body, vibration machine, bleach. All of these ideas are raw ideas which are coming from different students to solve the same problem. Now we ask them, how can you think of about this idea and what made you think of these ideas? The answer to that question is generally a frame which is identified by the students themselves. So, what made a student think that putting logs and extracting waste from the water can actually help the water get cleaned? What is the root of this idea? Why did they think of this? The frame which comes from the answer to this question is cleaning the water at source. When we say that cleaning the water at source is a frame, then a lot more ideas can come from the same frame as well, like putting nets along the river banks, water pumping, water surface cleaning. Now, this frame enables students to think of many more ideas which can come from the same frame. This enables students to think of much more ideas, and this framework helps them to create many more ideas to solve the same problem. This is how many frameworks guided by Erehwon's STEM innovation process help the student in creating multiple solutions and ideas to solve the same problem.
They did that, and then they came up with a very interesting solution, which is about we have constructed a solution to clean polluted water from water bodies. This is a mechanism which works on solar energy. It has it has a net which is attached to the machine which floats on water. Once this solution is written down, we ask them to use more digital tools like Tinkercad to come up with a digital prototype of a 3D model which we can directly print out and fit the electronics in, and then create a solution out of it. So all of this process we could do in 3 days, which would take around 1.5 months for a single facilitator to do in a classroom of 60 people, because we were taking help of a lot of digital tools and evolving the process at the same time. One more way in which this helps a lot is we get to see what this child and student is thinking when he's trying to make a solution. For example, this group has created a solution of cleaning the water at home, and they have created a very interesting prototype for the same. This tool enables us to see this prototype in real time.
So here we can add comments also, which will help students to get quick and real-time feedback. I think this prototype looks good, but I will say to them that you might want to look into the ruler. To my eyes, it looks bigger and might not go in the matka from the mouth. So better to find a smaller one which will be easy to place. Now, this problem has been anticipated by the mentor, and this mentor giving real-time feedback to the students reduces the time required to finish the prototype towards fruition. So, this is how the process actually helps students to finish the prototypes in real time, where they continuously keep adding the details about the prototype on each stage, and the mentor gives them suggestions and helps them with understanding how to take it forward.
And what it does at the best part of what it does is it allows scale documentation, value added facilitation which doesn't lose the interest, more engaging classrooms, and it also helps us in doing community outreach. Very interestingly, what did is the students were engaged throughout the program. When we tried doing this, they also documented everything they were thinking about. They wrote down the questions, they wrote down the ideation and conceptual solution at the when they were doing the whole exercises. Not only did it engage the student, but it created a repository of digital records of the whole process, which they can use in the further development of this model. If they want to show it to a mentor, the mentor already has a lot of documentation ready with him about how the student have come up with the final solution of this problem, and they can help them where exactly the process is lacking. So this gives a very good process visibility, and that becomes easier for the facilitator to assess these students on on the merit of on the merit of visibility as well. To solve some of the issues we incurred in using Miro, we tried to work with a tool called Canva also. So here also the same thing, they are doing documentation in real time. uh, there are 4 to 5 people in a team. They are writing some logic. We are also teaching coding to the students in some part of the training, because they need to have some technical understanding of how can they build prototypes as well. So here we can assess and see what the progress of each group is. We can understand how much of the logic they are understanding, how much of code they can write, and give them real time feedback. How does this work? We have created a structure for them to follow, in which they have to write the understanding of the program, how is it written, what is it, what all does it have, and document it properly. So whenever somebody comes and they have to show a prototype, they can show the whole process to the people who are seeing it. And then we talk about the whole problem statement. Then they have talked about the whole innovation process. What all did they do? How does the code work? What all technical things are there in the code? And why did they do what they do? How did they do the whole conceptual solution? And how do they want to make it?